I think we can do number 1 and number 2 on one board. So we are going to do number 1 over here. So number 1 says a sample of helium gas in a balloon is compressed from 4 liters to 2.5 liters at constant temperature. If the pressure of the gas in the 4-liter volume is 210 kPa, what will be the pressure in the 2.5 liter? What will the pressure be at 2.5? Man, reading hard. So we got a trapped body of gas undergoing changing conditions. So that makes me want to use P1 V1 over T1 equals P2 V2 over T2. Now, since it says the temperature is constant, we can actually just eliminate temperature from the equation altogether. So keep it simple. And then it says that at 4.0 liters, the volume is 210 kPa. So P1 is 4.0 liters. V1. No, come on. All right. All right. P1. So it's 4.0 liters. That's a volume. It's all right. And then the pressure when it's at 4 liters is 210 kPa. Asks what will the pressure be? So P2 is what we are solving for, and then V2 is 2.5 liters. I would like to see, before you plug numbers in, a rearranging of the equation. So we will go ahead and divide V2 over to the other side. And so that means that P2 is going to equal P1 times V1 divided by V2. So that means it's going to equal 210. Now let's, I guess, kind of think about this. If the volume is decreasing, right, so now the particles have less room to move. They're going to collide with the walls of the container more often, and so that pressure should be higher. So if volume decreases, pressure should increase. So if we would happen to get a number that's less than 210, that would be a good indicator that we did something mathematically foolish. 210 times our 4 liters divided by 2.5. And so P2 comes out to be 210 times 4 divided by 2.5. I get 336. Pretty much everything there was 2 sig figs. So we're going to go ahead and round P2 to 340. Now that needs a label. So liters, kPa, so that means P2 would come out also to be kPa. So that is our answer to number 1. Lecture example number 2. Another balloon that contains 30 liters of helium at 103 kPa. What is the volume of the balloon when the balloon rises to an altitude where the pressure is only 25 kPa? So it's actually the exact same kind of problem. It's going to be, so does it say anything about the temperature? Oh, at the end, parenthetically, assume temperature is constant. So we can use this exact same equation, P1 V1. Green? Yep. Green's had a rough day, so we're going to retire with Greeny. So we got P1 V1 equals P2 V2. So V1, it looks like, is 30 liters. P1 is 103 kPa. V2 is what we are solving for, and P2 is 25.0 kPa. 3 sig figs, 3 sig figs, 3 sig figs. Our answer will be 3 sig figs. And then kPa to kPa, that's cool. Liters, so that means our answer will come out in liters. So whatever answer we get will be 3 significant figures, and it should be in liters. since the pressure is decreasing, just like over here, so the pressure is decreasing, that's going to put less of a limitation on the container, and so the volume should expand, right? Because we need fewer collisions with the walls of the container. That means volume has to have more space. So then we're going to say, we'll divide P2 on over to P2 over to that side, and then so we've got 103 times 30 divided by 25 equals V2. And you plug that in, V2 comes out to equal calculator says 123.6. We agreed earlier 3 sig figs, so we're going to go ahead and call it 124 liters.